Alright, so in the previous videos we looked at what temperature represented and what pressure represented, and we also looked at the kinetic molecular theory. Now what we want to look at is the four gas laws. Before we look at those four gas laws, I just want to review what these variables mean. So this is some things that you want to write down in your notes. The T equals temperature, and remember, temperature is the kinetic energy, how fast the molecules are moving, the gas molecules are moving. P is going to represent the pressure. The pressure we're going to think of as how often the particles hit an object and how fast they're hitting the object. That's going to be our pressure. V is representing volume, so it's just the space that the gas takes up. And N is representing moles, which is just how many gas particles we have. So what we want to see now is what effect does the temperature have on the pressure of a gas, or what is the effect of the temperature on the volume of the gas. Each one of these is a variable that we can change, and if we keep the others constant, then we can see the effect of one on the other, and that's what our goal is in this video. So let's review what is a variable and the different types of variables. So variables are anything that can change in the experiment. So anything that can change in the experiment we call a variable. So with gases, it could be a temperature can change, the pressure can change, volume can change, and the amount of moles can change. There's three different types of variables. The first one being an independent variable. These are the variables that I change on purpose. This is the cause. The dependent variable is what is measured, whatever you're measuring, so the effect. And then the control variables is everything that you keep constant, that you don't want it to change, because we want to see, is this independent variable the true cause of the effect. So if we're looking at temperature and volume, if I change the temperature, what's the effect on the volume? That means I have to keep the pressure constant and the amount of moles constant. That way we're only looking at these two variables, and we can see what is the cause and what is the effect on each variable. So the first law that I want to look at is Avogadro's law. And what it states is, as N increases, so the amount of moles increase, volume increases. So how much space it takes up increases. Remember, if both variables go up and both variables go down at the same time, that's what we call a direct relationship. Okay, so when N goes up, volume is going to go up. This is a direct relationship. This is when we're keeping temperature and pressure constant. That means that these two are control variables here. This will be the independent variable. This is going to be our dependent variable. So I have a model that I want to kind of look at, and I'll pull it up here. Here's our model, and you can see that there's about 5 particles here, and it's really not taking up that much space. The volume's not that big here. So if I start adding molecules by pumping the air in, we should see that the more molecules, the larger the volume. Should be a direct relationship. So I'm changing how many gas particles are in there. That's the independent variable because I'm changing it. What we're going to measure is what is the effect on the volume. So if I give it a nice little pump here, we should see that the volume gets bigger. You can see they got a little moon walking backwards there. All right, the volume got bigger. If I give it another pump here, the volume gets larger again. So more atoms, larger are the moles go up, the volume's going to go up. So if I start taking away particles here, so I'm taking particles out, you can see the volume's going back down. Still taking volume out, particles going back down. Going down some more, and you can see that the volume is decreasing also. So this is again a direct relationship. If the moles increase, the volume increases. If the moles decrease, the volume also decreases. So that was Avogadro's law. So now let's look at Charles' law. And what Charles' law states is if the temperature goes up, the volume is going to go up. So this is another direct relationship. So if I increase the temperature, so that makes this the independent variable, the volume is going to be dependent variable again. So if I increase the temperature, we should increase the volume. So let's go back to our model. Okay, so here's our model. What I'm going to not change, what I'm not going to change my constant variables is going to be how much gas I have. So I'm not going to put any more gas in, and I'm not going to change the pressure. The only thing I'm going to change, my independent variable, is the temperature. So I'm going to add heat and see what happens to the volume, see what happens to the size of the box, and then I'm also going to remove heat and see what happens. So let's add heat. If we add heat, you can see that the temperature changes, and now the volume is also changing. The box is getting bigger. So temperature goes up, volume goes up. Now let's see if the opposite is true. So if the temperature goes down, the volume should also go down, and you can see the volume is decreasing. So remember, the independent variable is whatever I'm changing, so I just changed the temperature. The dependent variable is what's changing because I changed the temperature. That's what we measure, the volume. So temperature goes up, volume goes up. You can see this guy moonwalking back again, and temperature goes down, and volume's going to go down. So that was Charles' law. Remember, that's a direct relationship. As the temperature goes up, volume goes up. As temperature goes down, volume is going to go down. So just two more laws to go. The next law is Gay-Lussac's law. So what this states is if pressure goes up, temperature should go up. So if the pressure goes up, the temperature is going to go up. And this is, again, a direct relationship. So one goes up, the other one goes up, direct relationship. Now in this case, we're going to have to keep the volume constant and also how many moles we have constant. So let's go to our model. All right, here's the model again. So my constant variables are going to be how many moles. I'm not going to pump any more moles in here. And volume. So my volume is not going to change. I'm going to have this guy here. He's going to hold this container so it doesn't move at all. And what I want to do is change the temperature and then observe what happens to the pressure. So remember, if we change the temperature, if we increase the temperature, the particles are going to move faster. And you can see them moving faster. That means that they're going to hit the box more often and with more force. And you can see the pressure change. So increase in temperature and increase in the pressure. So we can see it again. Let's increase that. And you can see it increasing. If we remove the heat and lower the temperature, you can see that the particles start to move slower, not hitting as often the box, definitely not with as much speed, and the pressure has gone down. So temperature went down, pressure has went down. We can do this some more, really lower the pressure. Again, increasing the heat here makes them move faster, makes them hit the box more often, and that's what causes the pressure to go up. Alright, so we are finally at our last law, Boyle's law. Now this one's a little bit different because now this is going to be an inverse relationship. So these are going to be inversely related. So as pressure goes up, our volume of the gas is going to go down. So as the pressure goes up, as we increase the pressure, the volume is going to go down. And we can observe this with the model. So this is, again, an inverse relationship. So let's go to our model here. Okay, so we are trying to look at the effect that volume has on the pressure. So what I want to try to keep constant is the temperature and definitely how many particles are in the system here. So I'm going to use my little guy here to change the volume. So if the volume decreases, the pressure should go up. That's what inverse relation means. Alright, so here we go. Let's change the volume. So here I'm changing the volume, and you can see this ice pops up because it wants to try to keep the temperature the same, constant, and you can see the pressure is increasing. So we're here at 0.6, and I decrease the volume some more, and you can see it jump up and spike up. Keep going. The pressure keeps going higher and higher. Now if I increase the volume, the pressure should go down. That's the inverse relationship. So increase the volume here, and you can see the pressure goes down quite a bit, keeps going down here. So those were the 4 gas laws, and what I want you to get out of this video was remembering what a variable was, what's an independent variable, what's a dependent variable, what's a control variable, and the 4 gas laws. So each effect that temperature has on pressure, volume, and the effect of pressure on temperature, and the effect of volume on the pressure, and the effect of the moles on the volume of the gas. I will see you in class.